Software testing. It's kind of the secret ingredient, the hidden discipline that brings some much-needed order and control to the chaotic world of code. And really, getting a handle on it is the key to understanding why some software just soars, while other apps just crash.
Come on, we've all been there, right? You're in the middle of something important, trying to book that ride, transfer some cash, post the perfect photo, and bam, the app just dies. It is so frustrating. And that exact feeling is what robust software testing is built to prevent. But, the stakes are way bigger than just being annoyed. In the real world, a single software bug can have massive, massive consequences. We're talking about everything from crippling financial losses for a company to, in critical systems like healthcare or aviation, it can even pose a direct risk to human life. So yeah, getting this right, it's absolutely non-negotiable.
Okay, so how do we prevent all that chaos? How do we tame this beast? Well, it all starts with having a really clear mission. So let's dive in and break down what software testing actually is and why it's the absolute foundation of any quality software out there.
When you boil it right down, software testing is a systematic process. And the goal? Super simple. Find the errors before your users do. That's it. It's all about methodically checking and rechecking to make sure the software does exactly what it promises to do.
Okay, but wait a second. How do we know we're even testing the right things? It can't just be a bunch of random checks, right? A truly effective process is guided by two really important and very distinct ideas.
Let's break this down. On one side, you've got verification. The best way to think about this is like checking an architect's blueprint. It's asking, are we building the product right? Does it match the specs? But then on the other side, you have validation. This is like asking if that finished bridge actually takes people where they need to go. It asks the bigger question, are we building the right product? Because, you can have a perfectly built, flawless bridge to absolutely nowhere. And that's exactly why you need both. So, to guide us on this mission and make sure we're doing both of those things, professional testers rely on a set of core principles. Honestly, you can just think of these as the fundamental rules of the game, the things that ensure testing is actually effective, efficient, and, realistic.
All right, here they are, the 7 core principles that guide every pro tester. They remind us of some really important truths, like finding every single bug, totally impossible. Testing early, it saves a ton of time and money. Bugs, they tend to clump together. And of course, the way you test a banking app is going to be completely different from how you test a new video game. Now, we're going to zoom in on a couple of my favorites.
Okay, let's focus on 2 of these that I think are real game changers. The first one is this fascinating idea called defect clustering.
So this is basically the Pareto principle. You might know it as the 80-20 rule, but applied to software. And it is such a powerful insight. What it tells us is that roughly 80% of all the bugs are going to be found in just 20% of the code. So think about an e-commerce site, right? This principle tells you that the really complex parts, like the shopping cart and the checkout process, that's probably where most of the problems are hiding. Smart teams use this idea to focus their testing efforts where it's going to have the biggest possible impact.
All right, the next key principle is captured perfectly by this quote right here. It's a huge, huge warning against getting obsessed with just technical perfection. This is the heart of what's known as the absence of errors fallacy.
And here is the perfect example. Just imagine a mobile banking app that has 0 crashes. It's perfect. It passes 1,000 technical tests with flying colors. But the process to actually transfer funds is so confusing, so frustrating, that nobody can figure out how to use it. Is that a successful app? No way, it's a complete failure. So here's the crucial takeaway. A lack of bugs does not automatically mean you have a high-quality, usable product.
Okay, so we've got the what and the why. But how do we actually put all of this together into a practical process? Well, that's where something called the Software Testing Lifecycle, or STLC, comes in. Think of it as the step-by-step blueprint for getting to quality.
This 6-phase cycle is what gives us the structure. First, you start by understanding what even needs to be tested. That's requirement analysis. Then you move into test planning, where you figure out the strategy. After that, you're developing the actual test cases. Then, setting up the test environment, actually executing the tests, and finally, test closure, where you report on what you found. It's a really structured journey from A to Z.
Now, inside that life cycle, especially when we get to the execution phase, we have to decide how we're actually going to run these tests. And broadly speaking, there are 2 main ways to go about it.
First up, you've got manual testing. This is done by a real person, and it's fantastic for things like judging the user experience and getting that instant visual feedback. Then you've got automation testing, which uses scripts and tools. This is incredibly powerful for running thousands of repetitive tests over and over with perfect consistency. Now, the smartest teams, they don't pick one over the other. They use a strategic mix of both.
All right, let's bring this all home by looking at what not to do. Because sometimes understanding the common mistakes is the best way to make sure these principles really stick.
And you'll probably notice how these pitfalls map directly back to the principles we just talked about. Believing you can test everything? That ignores that exhaustive testing is impossible. Delaying testing until the very end? That violates the early testing principle. Just repeating the same old tests again and again? Hello, pesticide paradox. And, like we just saw, focusing only on the number of bugs you find, well, that's falling right into the absence of errors fallacy.
So all of this leaves us with the central challenge, doesn't it? The real goal isn't just to build a bug-free product. It's to build a useful one. It's not just about what the code does, it's about what the user can do with it. And mastering that balance, that tension between technical perfection and real human value, that isn't just the art of testing. That's the art of creating truly great software.